in this third international conference. I also want to express my gratitude to the both organizing and scientific committees for their excellent work in facilitating this event. So it's a great honor to present to you today on the topic Cellulose from Algerian Sources, Current Research, Challenges, and Future Perspectives. In this presentation, I will provide the fundamental aspects of cellulose biopolymer, its available sources in Algeria, current trends in extraction and processing, and its application. I will also highlight the challenges we face and the future directions related to cellulose-based materials. So currently, the need for renewable and sustainable materials for diverse applications has been steadily increased, owing to their biodegradability, low environmental pollution, as well as their potential and ability to replace the synthetic products derived from non-renewable and exhaustible petroleum sources. And in order to further elucidate the increase in biomass research compared to petroleum-based studies, a bibliometric analysis software was used based on the data extracted from Scopus database. So to generate this network mapping. In this network mapping, the circle represents a keyword or a popular term extracted from the titles and abstracts of the analyzed document. And the size of the circle is proportional to the number of articles or scientific papers related to each keyword. So the larger the circle, the more frequently the keyword appears. So it is evident from this network visualization that cluster focusing on biomass research is more prominent than that related to petroleum-based studies. In this field, several naturally derived polymers are available, with cellulose being the most abundant biopolymer in the planet. The significance of cellulose compared to other biopolymers can be also highlighted by this network mapping, which shows that cellulose is the most central and dominant topic of research related to biopolymers. Cellulose was discovered in 1838 by the French chemist Payen, who isolates cellulose from plant. The chemical structure of cellulose was determined later in 1920 by Professor Hermann Schwadinger. So this carbohydrate polymer consists of long chains of glucose units connected together by glycosidic bands. And the well-ordered structure of cellulose is provided by the strong inter- and intramolecular hydrogen bonding. At the industrial scale, the cellulose market is expected to reach around $42 billion by 2032, marking a significant increase over the next decade. This increased interest in cellulose-based materials can be further elucidated by the increased number of scientific publications as illustrated in this histogram. Recently, researchers and industries have been focused on the development of nanoparticles of cellulose known as nanocellulose or cellulose nanoparticles, which are mainly divided into nanostructural cellulose and nanofibers. And owing to its nanoscale size, it is found that nanocellulose provides more advantages compared to ordinary cellulose, like high increased surface area, improved mechanical strength, and also improved thermal stability, making nanocellulose a promising candidate to replace ordinary or native cellulose in advanced applications. Now I am going to present an overview of the cellulosic sources and review the existing reports dealing with the cellulose derived from Algerian sources. Cellulose is primarily derived from plants, but it can be also found in algal biomass, some bacteria, and sea animals like, or the mainly used is called tunicates. So this table summarizes the most widely used raw materials for cellulose production, including hardwood, softwood, agricultural byproducts, sea animals, bacteria, and algae. So these raw materials, along with their nomenclature, can be found in our recently published paper, which is recently recognized as one of the highly cited papers in Frontiers in Chemistry, with 900 citations. In the case of Algerian cellulosic sources, I have conducted a prospecting research study using the new artificial intelligence tool available in the Scopus database. So this tool is a powerful resource that provides a concise overview and valuable insights, which significantly streamline the research process. So based on this research, covering the period from 2003 to 2024, and using as keywords cellulose, cellulosic, Algeria, and Algerian, a total of 104 scientific publications have been identified, highlighting the Algerian contribution in this field, which is very limited due to the fact that large available sources are available here in Algeria, needing for more efforts to identify and explore other alternative and underused Algerian sources for cellulose production. So here are some examples about the already explored Algerian sources to produce cellulose, such as wood, alpha grass, and palm residues with cellulose content exceeding 35%. Here are two interesting papers which can be used as references for future works. The first review provides an overview on the distribution and coverage area of 5 underused Algerian sources, including alpha grass, palms, olive pomace, pincones, and tomato waste, highlighting their potential to produce cellulose. So the second paper offers valuable insights about the cellulolytic activity of around 400 bacteria extracted from various Algerian ecosystems. Here I have found that literature reports about cellulose or bacteria cellulose derived from Algerian microorganisms is very limited, presenting a challenge for future research. So here an example of the most cited papers related to cellulose derived from Algerian sources, including brown algae, alpha grass, giant reed, and palm fronds, and also this grass. This grass has been investigated by researchers from abroad, highlighting the global interest in Algerian cellulosic sources. Turning now to the extraction and processing trends of cellulose, which are very important and primarily determine their structure and and characteristics. So the extraction of cellulose from raw materials mainly involves the elimination of non-cellulosic components, mainly hemicellulose, lignin, and other extractives, with the characteristics of the resulted cellulose mainly depends on the cellulose origin and the performed processing methods. In addition, pretreatment, which represent over 40% of the processing cost, is very important to improve the quality and the purity of the extracted cellulose using various processes. However, some pretreatment can generate harmful byproducts, leading to imperfect separation and increased cost production, needing for more greener and alternative and eco-friendly extraction methods. So, depending on the cellulose source, different pretreatment and purification can be performed. In the case of cellulose derived from lignocellulosic plants, here are the case steps that should be followed to extract pure cellulose. In the case of or regarding cellulose extracted from algae and sea animals, this raw material undergoes the same chemical pretreatment as cellulose derived from plants. However, the extraction of bacteria cellulose is significantly different. Let's now take a look on the transition or the shift from conventional to alternative pretreatment methods to produce high purity cellulose, and these methods require the use of green bleaching agent, hydrothermal treatment, ionic liquids, dipeptic solvent as new technologies, organosolve process, biological or enzymatic treatment, which is based on the use of enzymes, and lastly, mechanical processing, which are based on the use of advanced steam explosion, ultrasound-assisted pretreatment, and microwave-assisted pretreatment. So for more details about the conventional and alternative extraction methods, their advantages and drawbacks, as well as their effect on the cellulose origin, you can see these interesting reviews. To the best of my knowledge, literature reports about the eco-friendly and green extraction of cellulose from Algerian biomasses are very limited. And here are some examples addressing the green extraction of cellulosic biopolymers with the use of green hydrogen peroxide instead of the conventionally used sodium chloride oxidation agent. So now I am going to present an overview of the current applications of Algerian cellulosic products focusing on both civilian and defense applications. So the inherent and the attractive characteristics of cellulose and its derivatives have promoting their use in both civilian and defense applications. So in civilian sector, cellulose is mainly used to produce second generation bioethanol, water and air filtration membranes, biomedical products, and sustainable packaging materials. In the military field, nitrocellulose, which is designed by the nitration of cellulose, is considered as the main component used to produce gunpowders and solid rocket propellant. In order to further elucidate the potential applications of cellulose-based materials, I have performed a bibliometric analysis study using Voss Viewer software and based on also the data extracted from Scopus database. So this bibliometric study yielded around 32,000 scientific papers related to global research output. Among this, Algerian researchers only contributed 106 scientific publications, highlighting the significant gap regarding Algeria's contribution compared to worldwide. So here are some examples about the potential use of cellulose extracted from Algerian feedstocks. So cellulose-based materials can be used as frame retardancy systems, as membranes for environmental purification, and also as reinforcement for textiles and paper making. In the case of the military use of cellulose-based materials, this topic has been has been deeply studied by our research group at EMP, and we have made several advancements in the development of new energetic cellulose-rich biopolymers with improved performance for potential use in ammunition. We have also developed new cellulose-based hybrid to be used in defense equipment. Now I am going to present the last part in this presentation, which is dedicated to the challenges and future directions related to cellulose research. So here are some key challenges related to cellulose research, which have limited its broad applications and commercialization, and these challenges can be divided into cost and scalability, compatibility issues due to the hydrophilic nature of cellulose, environmental concerns of traditional extraction methods which generate hazardous byproducts, dissolution and nanomaterial shaping of nanocellulose have limited its advanced application, its advanced use. Also, the need for sustainable pretreatment methods of lignocellulosic biomass for second generation bioethanol production. So, having analyzed the key challenges, it should be noted that these challenges present also opportunities for innovation. It means that by addressing these challenges, researchers can explore new directions or future directions to drive advancement in cellulose research. And here are some key advancements, such as improving manufacturing efficiency by the optimization of the extraction methods, the valorization of alternative and underused Algerian local sources, improving cellulose properties by introducing some specific chemical groups to obtain hydrophobic surfaces. Also, development in nanotechnology are driving innovation in nanocellulose for advanced application. Also, addressing safety and commercial aspects is very important to the market introduction of nanocellulose. In addition to the establishment of standard terminology to make easier collaboration or to make easier international collaboration. And the most important is promoting national and international collaboration in cellulose research to address complex challenges and driving advancement in cellulose-based products here in Algeria. So in the next section, I'm going to focus on this point. So the objective here is to provide a comparative analysis between Algeria and global contribution in cellulose research. So based on the data extracted from Scopus database and using a bibliometric analysis software covering the period from 2010 to 2024, a total of 143,000, around 143,000 documents have been analyzed to generate this network mapping, which represent the most productive countries in cellulose research, with China ranks first, followed by USA and India. So based on the extracted data, around 195 countries have been contributed in Cellulose research with a minimum of 5 documents. And among Arab countries, Egypt ranks first, followed by Saudi Arabia, Tunisia, while Algeria ranks fifth among Arab countries and 56th globally with a total of 423 documents. So in order to improve the impact and presence of Algeria, some actions can be undertaken. In addition, it is evident from this network mapping that Algeria has also established collaboration with other countries, such as Saudi Arabia, Tunisia, France, Spain, Germany, China, Malaysia, and South Korea. In order to further elucidate the Algerian contribution in cellulose research, a bibliometric analysis of the most productive Algerian institution and individual authors have been done. So the obtained results show that USTHB is ranked as the top contributing Algerian institution in cellulose research, followed by Boumediene University, Bejaia University, and EMP. It should be noted that this classification depends on the date when the research was performed. So if we perform the research today, we can find another classification. In addition, this generated mapping shows that the research group directed by Professor Trash at EMP ranks first among individual authors with a total of 60 scientific publications. And the most important, we can deduce from this network mapping that there is a scarcity of collaboration between individual authors, between authors from different institutions. So promoting cooperation and partnership between Algerian research will be benefit for both academic institutions and industries here in Algeria. So to conclude, the study of cellulose from Algerian sources highlights the significant potential for local sources for the production of cellulose, contributing to a more sustainable and bio-based economy. The extracted cellulose from Algerian sources has been characterized and investigated for potential applications as a reinforcement agent and energy-based systems. Continuous research efforts are focused on improving extraction techniques, enhancing physicochemical properties, and expanding the use of Algerian cellulose derived from Algerian sources. And finally, this research highlights the importance of establishing strong national and international collaboration between academic institutions and industries to drive innovation and commercialization of cellulose-based products here in Algeria. Before finishing my presentation, I would like to thank again Professor Khazi for the kind invitation. I am also thankful to my co-workers and colleagues from EMP, Professor Taraj, Dr. Abdelaziz, Dr. Bakhouj Sliman, and my two PhD students, Boumaza and Bouxiat. And also I would like to thank the organizing and scientific committees of the JEMP 2024. And thank you for your attention.